doing that, nothing really wrong. You just do this. Maybe that's the preferred way to do it if you want to use UV parameterizations. So that would be the same. And then where are UVs? UVs are circles. Right. So the parameterization is done. Either this or that. It really doesn't matter as long as you know what you're doing. And to set up a double integral for the surface area, namely how much this is. Remember, this is a special case where we have a surface area is specifically given by a double integral of d square root 1 plus zx squared plus zy squared if you have a surface given by a function. Namely, you do not have to go through RU cross RV for this case. However, if you're using spherical coordinates, which you could do, then you have to go through RU RV. Because spherical coordinate parameterization is not in gravity situation. So you have to do that specifically. So that's why you had an advantage if you go because of the situation. You can write it down like that. And what you really have to do is just take derivatives of these functions. I'm just taking derivative right here. Let's take one because of the symmetry. Zx is 1/2 of 5 minus x squared minus y squared, negative 1/2 times negative 2x. So cancel out. That's minus x, 5 minus x squared minus y squared. That's 1/2. You square this, it'll give you x squared over 5 minus x squared minus y squared. The square of this is a negative 1, becoming denominator. So that's the zx squared is this. By the way, if you're doing this again by yourself, you just go through the details of all the algebra. And the same token. But that's not enough. You want to be simplifying it more. So it's just same denominator, and you will cancel out both the numerator, leaving you just 5. Okay. If you add 3 of these together, then you see square root of 5 is part of the dummy number. What you're really doing is the integral of so that's what I meant so far. A double integral simplified in a way like this. And that's not enough. That's not enough. You want it as clean as possible. However, if I insist you find the area of that, it's not too hard either. It's polar coordinates. So it's an optional one. Just let you know how you integrate this anyway. It will be 0 to 2 pi and 0 to the square root 5 over 2. D. Okay? That shows the radius. It will be equal to 5 minus r squared dot r dr d theta. That's a standard integral you have to be able to handle, which is square root 5 times 2 pi. There's no theta. You have r dr, anything have r squared is a substitution of basically integrating this. 5 minus r squared minus 1/2 of r dr. Okay. And you make substitution of u being 5 minus r squared, and du will be 2r dr. That's exactly what you're looking at. Of yes.
Why did you factor out square root 5?
Well, it's just for that matter. it's a constant. You always take a constant out of it. It's square root 5 over square root.
Okay.
It's the algebra. That's a common practice.
I thought the square root was only a root.
No. 5 is part of the square root. You take away anything you don't want part of the substitutions. Namely, you don't want to substitute with 5 either. It just makes things unnecessary. And that would be, so the integral, what you're doing is the integral of u negative 1/2 regardless who you are. So I'm not finishing the remaining numerical value of n to make sure you do. Okay. So. Any questions regarding this part? As I said, even some of you don't listen to me. This is how you to be best taker, but bad at test the final taker. You try this variable, nothing wrong with that. Actually, it's a good one. But you have to go through all the procedures in terms of RU cross RV. And that's another 10 minutes work to go through chances you get it wrong and you never get it right. So you can recognize this is the case where you can take advantage of graph a function, you have a formula. I read a shortcut called cross, minimizing the chances of getting great mistakes. And also in the program, eventually use a program, but in two variables. Okay? So make sure that you listen to improve. So that's my slogan.